Okay, this activity demonstrates the Coriolis effect. If you draw a line from the North Pole down to the equator, what would you expect to see if the globe is not turning? Pause and make a prediction. You should see a straight line. Now if we rotate the globe, predict what the line would look like. Pause and make a prediction. You should see the line curve. Now take a second and answer the question, what does the line on the globe represent? And now you can officially answer what happened to the line as the ball rotated. When looking at the North Pole, what direction do you see your line curve? In order to see that, we're going to turn the globe this way so it's facing the camera. My line was going this direction when it wasn't moving. Now you see it moved over this way. So my line moved to the right. When looking at the South Pole, what would you expect to see? If I were to do it opposite. Now on the South Pole, you're going to see it rotating the opposite direction. And if I draw a straight line, you're going to see in the South Pole, it's going to veer off to the left. Here's why. The Earth rotates in this direction. If I continue to spin it in that direction from the North Pole, you'll see it moving counterclockwise. And I'm going to continue spinning it in the same direction. If we go to the South Pole, now you should see it's rotating clockwise. What happened to the line as you got closer to the equator? If this is our equator, you should see our line not getting deflected nearly as much. Again, at the North Pole, it gets deflected a lot. But as we continue to draw straight lines and see how it gets deflected, that's not a very big angle, so it doesn't get deflected very much at the equator. In fact, directly on the equator, there is no Coriolis force. Let's test to see how the speed of the rotation will affect the Coriolis force. So if we can do some extreme, so if it's not moving, we see it's not getting deflected at all. If it's moving at a, we'll say, medium pace versus a fast pace, the fast gets deflected the most. So this is our fast, this was our medium, this is no turning of the globe.